later on when we discuss the TQM framework, the quality management framework, you will find that the management, the commitment is one of the important pillars. Deming recommends 14 points for management to provide the necessary sense of direction. It's clear? So what are these points? Is it okay? So you should be aware of. So one by one, I'll tell you what are these points. The first point is create a vision and demonstrate commitment. That means it must comes from the top management. Suppose you are a mid-level manager. Okay, you try to implement, the quality control. Okay, tools and techniques in your organization, but the top management is not at all interested. It doesn't bother about what is quality control, what is quality assurance. So you can just carry out some work on quality, but it will not be a part of the system. So what we try to do, that means whenever you say that I will initiate some quality improvement program, okay, so it must be a part of the system. Obviously, the top management must have a vision related to the quality. Learn the new philosophy. Is it okay? That means it is essentially, the situations are changing. Is it okay? The kinds of technology you use changing. The kinds of the work environment that you face today, constantly it's a dynamic system. Constantly it is changing. So what is the new philosophies, the new approaches, new tools and techniques? You must be motivated to learn all this one. Getting my point? It's not that you just stick to the few kinds of tools and techniques and approaches and you say that's all, right? So it's a dynamic system. Understand inspection. Is it okay? In the last class, if you remember, I've mentioned about inspection-based quality control. Is it okay? Stop making decisions purely on the basis of cost. Cost is definitely very important, in fact. Price at what cost, quality at what cost. But sometimes what happens that any new proposals you propose, okay, you initiate, the management may be overburdened with the cost, and they say unless and until you say that this is a cost effective one, you will not be given any permission. Is it okay? So cost is definitely important, but along with the cost, the benefits, okay, the values, that also you must also consider. Is it okay? So improve constantly and forever. It's clear? That means you must adopt the philosophy of continuous improvement. Continuous improvement, which in the there is a Japanese term which is referred to as Kaizen. Kaizen. Okay. So this philosophy, that means continuous improvement philosophy, you must be able to adopt. Continuous improvement. If you say, okay, I have created the waste system and no further improvement is required, then what you will find, that subsequently they invariably will find the deterioration in your performance. Is it okay? Institute training has to be there. Okay, training. That's why you will find all the good organizations that training cell is very, very competent and it's very effective. Is it okay? Institute leadership. Okay, that means leadership is also one of the pillars of TQM. I've already mentioned, in fact. So you are aware of different kinds of the leadership style. Like sometimes we say command and control. Command, control. Similarly, the participative management. Participative. Is it okay? These days we say, this leadership style we say the level 1 leadership, level 2 leadership, level 3 leadership. And today's context, they say, why don't you adopt, you must have the level 3 leadership. Is it okay? Level 1 leadership may be 100-year-old, 150-year-old kinds of leadership. That is essentially command and control. Okay, I will just instruct you. I will just ask you to do something. Okay, so you have to do that. That's sort of the leadership style, right? Now today you cannot in majority of the cases, right? So if you follow this leadership style, many kinds of problems you cannot solve. It's clear. So so you should be aware of in a given situation what sort of the leadership style is needed. Drive out fear, the management by fear. Okay, right? So simply this is not a feasible technique, right? Management by fear. If you do not do this job as per the my wish, then I'll not maybe so your performance will be affected and you will not be given promotion. Okay, it's like this sort of the leadership or this sort of approach will not succeed in the long run. There are numerous cases. Okay, it's just a short-term approach. Drive out fear, optimize the efforts of team. That means the teamwork, right? The problem you face these days is very, very complex in nature, right? And you need a multidisciplinary approach. So almost all cases you will find the team is formed and how effective the teamwork is. So optimize the efforts of team, eliminate exhortations. Okay, what do you mean by eliminate exhortations? Means I will ask you to do something, right? And I will just insist on, right? You have to do this. Is it okay? This is my target. You have to achieve this. No question. It's like this sort of attitude, right? Then eliminate numerical quotas and management by objectives. Management by objectives is an important, say, you can say that for the productivity improvement tool or some kind of measures, mainly made for so the people who are working at the middle management level or so some cases top management level. Okay, MBO. So in 50s, the Peter Drucker, he proposed this one. Many companies have adopted. Subsequently, the situation has changed. The work conditions has changed. Okay, the kinds of relationships you have between you as a superior and the others, your subordinates, the kinds of relationships is changing. It's okay. So in many cases, it has been found that if you set some numerical quotas and you are only bothering about, okay, that means how to achieve those numerical quotas and nothing else, and to some extent you apply MBO techniques all the time, so you may not succeed. Remove barriers for pride in workmanship. That means directly or indirectly what we are saying that the workers, so their worth, their potential should be recognized all the time. As you may be aware, I have already mentioned, there is a concept called line-centered management. That means person who is working on the job, he is the best person to suggest for improvement. So recognize his potential. Encourage education and self-improvement. This is always you have to do. That means there are different kinds of the training programs we initiate, and as you know that the basic or the necessary condition is your educational qualification. Is it okay? So the education comes first, and then with respect to your job, you go for the training programs. Is it okay? There are the two aspects. One is what is your capacity, inherent potential, and the second aspect is what is your fitness. So these are the terms. What is the fitness? Fitness means with respect to certain job, you have the ability. Is it okay? So whenever you say that what is your level of fitness, you are referring to some kind of job. Is it okay? So there is no such concept like say fitness for any kinds of jobs. Is it okay? So and the take action, right? Take action is very, very important. So these are the 14 points as a management related. Is it okay? Must be aware of. So what you try to do, that means the improvement is essential. Whatever the activities you do, when we say that what is the purpose of running an organization, is it okay? So the first purpose is we say make money. Is it okay? Make money. What is the second purpose? The second purpose is continuous improvement. That means today you are doing your work in a particular manner, in a particular way, and whether tomorrow, okay, you are doing the same job in a better manner or not. Is it okay? So this is essentially, so they must believe in this kind of philosophies. There's always improvement is visible. So now, as far as improvement cycle is concerned, the Deming has pointed out the 5 steps. So what are the 5 steps? And it's a loop. It's a cycle. Conduct customer research and use it in planning the product. That is called plan. So that means any assignment you accept, carry out, the first thing is you must be able to plan, right? Next is produce the product. That means with respect to the product development, I'm explaining this one, right? So your objective is product development. So first thing you do, like the conduct customer research and use it in planning the product, right? That is first step. The second step is now you have to produce the product. So what is the the primary conditions you have to fulfill before you produce the product? That means you must know the design of the product. Is it okay? Design of the product. And as far as manufacturing of the product is concerned, you also must know what is this process plan. Is it okay? The process plan. Unless and until you have a process plan, how can you produce the product? Okay, under given constraints, under given situation. Produce the product, do. Check the product to make sure it was produced in accordance with the plan. That means suppose as per the plan means suppose the quality and quantity. Is it okay? These are the important aspects to be considered. So quality means okay, conforming to specifications. So first there must be checking that at each step, at each stage of the production, whether you are able to meet the quantity requirements as well as the quality requirements or not. Then market the product, right? That is the act. Analyze how the product is received in the marketplace in terms of quality, cost and other criteria. That is called analysis. So it is essentially P, D, C, A, A. Okay. Initially you used to say there is just a 4-step process, P, D, C, A. Is it okay? Now we add analyze phase also, okay, in the cycle. So this is the cycle: plan, do, check, act, analyze. Now you must be able to the differentiate between do and act. Is it clear? Getting my point? That means in the given context you must be able to define what is do, and in the same context you must be able to define what is act. Don't get confused. It's clear? Right. So this is important way of looking at. Is it okay? It's the ideal way of looking at the improvement cycles. So this is also referred to as the Deming cycle. Now the Deming has mentioned several kinds of problems the organization may be facing. Is it okay? As far as quality management is concerned, is it okay? Because the quality management is a total concept. And he refers to these kinds of problems as deadly diseases. Is it okay? Deadly. That means if is one of these diseases, okay, are not cured, are not removed, there's every chance that the company will die. There are many such cases. So he has identified the 7 deadly diseases. So I'll just read it out and you'll get the meaning out of it. Lack of constancy of purpose. One term is constancy of purpose. To plan products and services that have a market sufficient to keep the company in business and provide jobs. Now the 2 specific terms he has used. One is the constancy of purpose, and the second term he uses, that is consistency of purpose. Consistency of purpose. So what is constancy of purpose? That means you have several departments. Is it okay? You have several departments. You want to implement the quality improvement program in your organization. It just cannot be the responsibility of one department or one section. So if you set a quality goal for one department, you also must be able to set quality goals for all the departments. Is it okay? That means there must be a goal related to quality. Okay, and constantly, you set the goals, you set the target. Okay, you must be on the same path all the time. Is it okay? It's a common goal. Quality improvement. Whatever you do, whatever the activities you do, is it okay? Whether it is a manufacturing activities or service activities, supporting activities, for all sorts of activities, for all sorts of sections, okay, there must be a quality goal. Okay, you must not think that it is the responsibility of the top management or the responsibility of one department. Is it clear? So now what do you try to do? Always, that means the performance. Is it okay? Quality related performance. Single minded. Sometimes we say single minded, the devotion, one direction. So that path you must follow. Quality improvement path. Everyone setting the target. Then what you do? That means along this path is the target, but always there will be deviation from the target. You cannot avoid. Is it okay? So the deviation path may be like this. Initially the deviation could be more. Later on the deviation comes down. Is it okay? Initially when you start, you say the deviation could be the plus minus 20-25%. Is it okay? That means it is like this. There is a path. Getting my point? So initially when you start, it is expected that there will be lots of deviations. Okay, plus minus, you set a target of say suppose I want to have a utilization of the facilities. Is it okay? Right now it is 50%, right? I want to make it 70%. 70%. You set the target 70, but around 70s there could be deviations. So all the time. So you have to monitor this deviation also constantly, so that ultimately what you find that the variation, the level of variation gets reduced over the time period. So this is the time. Getting my point? So this is your constancy of purpose and this is your consistency of purpose. It's clear? So sometimes in this context we say that any exercise on quality in an organization is essentially an exercise on variability. Is it okay? So variation is a part of the system. You cannot avoid it. Only you can reduce it. It's clear? So this is, so you must not deviate from your path, right? So constancy of purpose and consistency of purpose. These are the two goals. Emphasis on short-term profits is a disease. Is it okay? Short-term profits. Short-term thinking that is driven by a fear of unfriendly takeover attempts and pressure from bankers and shareholders to produce dividends. Is it okay? As a short-term means, the penny wise, pound foolish. Right? That sort of situation. That means you don't bother about what is going to happen after 1 year. You think about today and tomorrow. Okay, even you don't bother about the situation, okay, that you might face in the next week. Short term. Is it okay? There are numerous cases come across where this short term thinking has brought disaster. Totally the company later on you'll find, okay, on the short term I am just chasing for the short term gain, but I don't have any idea that what is its implications in the long run. Is it okay? Somehow you are trying to managing the show. This attitude will bring disaster. Is it okay? So there are many such cases. Like in some cases what happens, for selecting a supplier, I'll tell you, for selecting a supplier, what do? You go by, the norms and the lowest price quoted. It's clear. Now we say that you must not consider only the first cost of purchase. While you select the supplier, right, you also must consider the total cost of purchase. Is it okay? So if someone believes in the concept of first cost of purchase, okay, the first cost of purchase, the price is less. When if the price is less, the quality is not that good. If the quality is not that good, you start using that material in your machine, and the machine frequently breaks down, and ultimately you will have to bear this cost. Is it clear? But supposing you go for slightly higher price, so the quality is better. So it's all likelihood that your production system will not be disrupted, right? And there will be smooth flow. So the total cost of, so you must have a mechanism to measure, to estimate the total cost of purchase. Is it okay? So the first cost of purchase versus total cost of purchase. Total cost of purchase. This is just an instance, I am just citing total cost of purchase. Okay. Personal review systems for managers and management by objectives without providing methods or resources. You say, okay, suppose why don't you you go for MBO or MPBO, like managing productivity by objectives. Sometimes they adopt. The basic concept is management by objectives. So you say my goal is productivity. Now you say that why don't you implement, but you do not suggest any approach without providing methods or resources to accomplish objectives. Many of you may be aware of some kind of, suppose an improvement plan is to be made. Is it okay? As a new project is to be taken up. So what is how do you create, or how do you write the project proposals? Is it okay? So what is the format of the project proposals? So here you also must mention that what are the methods we should follow, what are the approaches, and what kind of resources you require for implementing any sorts of ideas or the concepts. Okay, what you require, you need resources, the physical resources as well as the human resources. So you must be able to mobilize these resources as per a given plan. Performance evaluations, merit ratings, and annual appraisals are all part of this disease. It's clear. That means you are not giving them enough resources, you are not giving them sufficient number of approaches. Nobody knows what is to be done, but you are the putting pressure on them, why your performance is low, why your performance is not up to the mark, like this. So this sort of approach ultimately will not bring any kinds of benefits to your systems. Job hopping by managers is a serious problem in many organizations. What we have found in many defense organizations, right? Sometimes the job hopping is a serious problem. Fifth one, using only visible data and information in decision making with little or no consideration given to what is not known and cannot be known. But when you start analyzing the problems, suppose you ask your the workers, okay, henceforth it's an open system, so why don't you come forward with your problems. Okay, I am committing to you that your problems will be solved. Okay, now what will happen initially, you will find that there may not be that responsive, only few problems come. So they are also testing you, whatever you are saying, whether really you are believing in that one. So initially, suppose you say, okay, they find that then a few problems really you are interested, or you, with all your command, with all your the resources, with all your ability, you have solved their problems. Is it okay? Next, what you will find, that now you will be hundreds and thousands of problems from different levels you may come across. That means the kinds of problems you are observing, it's just a tip of the iceberg. Once those problems, okay, are appropriately handled, you will find that that means in the process what happens is the trust develops between you and the worker, between you and the subordinate. So now he comes forward with more number of problems. Are you getting my point? So this is very, very important. That means there are many problems underneath, or the hidden is not visible. So you must be aware of. In many cases, we go for identifying. There could be many kinds of symptoms, but what is most important is what are the causes. Is it okay? So the cause identifications is the main goal of any quality improvement exercise. Excessive medical costs. Is it okay? So you can, if in any organizations, if you find that their medical costs or the budgets are increasing and there is no control over it, that means something is seriously wrong in the system. Getting my point? So ultimately, what is happening in the long run, if it goes unchecked, is all likelihood the company becomes sick. Not only few persons, the medical cost. It's okay. So the entire company they become sick. There are many such examples. Excessive cost of liability driven up by the lawyers that work on contingency fees. That means there is another dimension. That means the cost due to the litigation and all. That means you are in dispute with many parties all the time. How long you can continue with this? Getting my point? So if you find that more number of litigations, more number of court cases, okay, and these company officials are always visible, is it okay? There are many kinds of disputes. Even if the company is a very old one, but there is no guarantee that it will survive. Is it okay? It has survived for the last 100 years, and you will find that within 6 months, within 1 year, it is just out of the market. There are many such cases. In fact, you must be aware of those situations. It's not that the longevity of a company, okay, is an assurance that it will continue forever. Is it okay? Okay, so these are the 7 deadly diseases. Now the Philip B. Crosby, okay, he has also contributed a lot significantly to the cause of quality management or in the field of quality control. Is it okay? So what is his contribution? Let us study these aspects. His approach begins with an evaluation of the existing quality system. Is it okay? That means wherever you go, whatever the organizations are given to you, okay, you must be able to evaluate its quality management system. or assessment. Is it okay? His quality management grid, I will explain it very soon, you will come to know, and how beautifully he has explained the situations. Okay, his quality management grid identifies and pinpoints operations that have potential for improvement. Is it okay? It has got 5 phases, right? From uncertainty to certainty. Is it okay? Quality grids. The grid is divided into 5 stages of maturity and 6 measurement categories. That means what you have essentially, you have a structure like this, right? So these are the 5, the maturity levels. So the 1, 2, 3, 4, 5. Okay, this one is uncertainty, this is a certainty, and then you have the several the 6 measurement categories. These are measurement categories: 1, 2, 3, 4, 5 and 6. It's clear? Okay, so this sort of table you just write. Okay, now first let us talk about these measurement categories. That means category number 1, measurement, management, understanding and attitude. That is the first category. Is it okay? That means this is basically the maturity level on this side, and this is essentially the measurement category, measurement. Okay, so these are the rows and these are the columns. So what are the measurement categories? The first one is the management, understanding and attitude. That is the first one. It's most important, in fact. Then quality, organization, status. Is it okay? First one is a general one, management, understanding and attitude. The second one, we are focusing on the quality, organization, status. That means whether the company is an old one or new one, whether the company is what you can say is a good one or a bad one, right. So there is a quality status. Is clear? So you first you must be able to assess it. Then the third measurement is how do you the problem handling. Fourth one is the cost of quality as a percentage of sales. That means sales at what cost. Are you getting my point? In another context, when you refer to profit and loss statement, the first the data you have, that is the sales minus the cost of goods sold. That sort of term we use, but here what we say, the cost of quality. Is it okay? So in the last class I mentioned that what are those the different types of cost elements. Okay, you need to consider there are 4 types of cost elements you need to consider to get an idea about the total cost of quality. So what you try to do, these are all measurable. Is it okay? In terms of monetary units. So what is the proportion of the cost of quality as a percent of sales? Is clear? There is a proportion. Quality improvement actions, and then the summary quality improvement actions and the summary of company quality posture. Is it okay? Like the summary of company quality postures, like we say that when you are in uncertainty stage, you say really we do not know why there is the quality problem in our organizations. There is uncertainty stage, whereas in the certainty stage, that means your maturity level is at the best possible one. Is it okay? The highest level of maturity, certainty stage, you say yes, I really know that why there is no problem related to quality in my systems. Are you getting my point? We do not know why there is a problem. From this status you are moving to the best possible status. We really know that why there is no problem. Are you getting my point? So that is the challenge. So what are the stages of maturity? The first one is uncertainty. Just I have written one statement. We do not know why we have problems with quality. Okay, so when you join a company, okay, so you just on your own you can assess that whether you come across several situations, right, several kinds of problems, and on your own you are assessing the situations. Say what kind of company I am working with. It's clear. So one way to look at that, in uncertainty stage, the company, as far as quality is concerned, the company is really in uncertainty stage. So what is that? We do not know why we have problems with quality. Awakening. Someone starts talking about quality. It's not only the design is important. There must be a separate effort for quality improvement, the separate cell. Someone starts talking about. That means he has heard about the importance of the quality management systems. So is it absolutely necessary to always have problems with quality? You start asking questions. Is it okay? The people are becoming, aware, okay, about the importance of quality. Next one is enlightenment. Some more information you have collect. So through management commitment and quality improvement, we are identifying and resolving our problems. Getting my point? That means you have gone one step further. Is it okay? Not only you are aware, you are also getting enlightened. That what is this one? Management commitment is very, very important. Okay. So this way you are getting yourself enlightened. Then the wisdom. Defect prevention is a routine part of our operations. That means what you are trying to do, that means you are initiating different projects, different improvement plans. Is it okay? And out of this, through these implementations, okay, and handling, of implementation of the different kinds of, the approaches or the tools and techniques, you gain knowledge. Is it okay? And ultimately you are becoming wise. So what you are saying, that the defect prevention is a routine part of our operation. Initially it was the defect detection. Is it okay? And then that means from the detection mode you are moving towards the prevention mode. Is it okay? I have already mentioned that any exercise on quality control means essentially you are working in the prevention mode. Is it okay? So that means you are reaching that level of say the maturity, and this is called wisdom. And the last one is certainty. We know why we do not have problems with quality. Is it clear? Is it okay? Okay. So this is the maturity matrix. Now he has also put forward the importance of 4 aspects of quality, quality management. What are those? First one is there are many definitions of quality. Is it okay? There are many dimensions of quality, and what you say that these are classified at the stated dimensions, stated quality versus implied quality or the brand name. That's an ultimate goal. So what is the definition of quality? Quality means conformance to requirements. Is it okay? Conformance to requirements. The second one is that what kind of systems you must have for achievement of quality. The rational approach is prevention of defects. That's it. Today it may be the detection, but tomorrow, okay, you must convert yourself from detection to prevention. Okay, so that is the only way you can improve the quality level. Performance standard, the only performance standard is 0 defects. Is it okay? So this 0 defects program, right, 0 defects, ZD programs. Initially it was initiated by US Department of Defense. Is it okay? In their Pershing missile project, and these 0 defects programs, the program was what you can say is launched more than 50 years back, 55 years back, December 1961. It's clear. So in the ZD programs, they say that why there are problems in quality. Is it okay? You are producing products, you are producing parts, components, assemblies in a manufacturing system. in a production system, and there could be the many reasons that why you are unable to produce a quality product. So these the problems must be classified. So it says that there are three possible reasons. One is your materials quality could be very bad, okay, maybe very, very bad. Is it okay? And that's why your product quality is inferior, right? What could be the second reasons? Suppose the material quality is acceptable to you, right, but still there could be problems with quality. What is the reason? That means the equipment which you use, machineries and equipment is used, it's not performing well, or they may be of inferior quality. It needs replacement. You're getting my point. What is the third reason? The third reason is the human error. Third reason is human error, right? So the materials quality can be improved. Is it okay? Equipment quality also can be improved. There are solutions for this one everywhere, right? Third one is the human error. Even if the material quality is very good, the equipment quality is acceptable to you, but still there could be deviations. And why these deviations? You say human error. So human errors are of two types. One is unintentional. But there could be intentional. It's clear? So unintentional means you want to perform very well. Is it okay? You are intrinsically motivated, but somehow you are making mistakes. Getting my point? Your attitude is positive. So it's a question of, say, aptitude. Is it okay? It's a question of aptitude. Whereas if it is intentional, what is the reason? That means it's a mindset. So it is essentially attitude or the mindset. So what is ultimately required? This is a solvable problem. This is a solvable problem. This part is also a solvable problem. Is it okay? You initiate appropriate training programs on the job, off the job. Is it okay? And subsequently you will find there is hardly any unintentional human error. So the main question is how to avoid these intentional human errors. So when they launched this program, so entire zero defects programs essentially directed to how to minimize, how to eliminate the intentional human error. Is it clear? So this is the zero defects. So ultimately, what is your goal? That means the rejection percentage. Okay, gone are those days. You say, okay, the rejection percentage, fine, the 5% is allowed. Is it okay? You cannot set this sort of the target these days. You say my goal is 0. Okay, so like in many cases, you try to adopt the GIT based manufacturing systems. GIT based manufacturing system. So in the given context, you also must be aware of the GIT based manufacturing system. So it says it has got several goals together. So what are those? These goals. The first one is the zero defects. Zero defects is your goal. Even if today your the defect rate is say 1% or 1.5%. Okay, you say that okay, I need to reduce it. If it is 1.5%, why not 0.5% within next 6 months of time? And if you achieve 0.5%, why not make it say 0%? So the goal is 0. The limiting value is 0. So the zero defects, then you have zero inventory, then zero setup, and all these goals you have to achieve simultaneously. Zero setup. So okay. Then the lot size of 1. Then zero handling. Getting my point? So these are the few goals you try to achieve simultaneously in any manufacturing system. So wherever feasible, you try to adopt. It's the JIT based, the JIT philosophy, just-in-time philosophy. Okay, sometimes in another context, it is referred to as zero setup. Zero setup means, when you talk about the total throughput time, suppose you have, I'll tell you, total throughput time you need to monitor. Suppose you have n number of production stages. Is it okay? Starting with 1, 2, ending with n, suppose. So here there the raw materials are entering, and from the nth stage you are getting the finished goods. This is a typical. So it is the raw material and it is the finished goods. Getting my point? Now, what do you try to do? Suppose your workload is say 1000 units. 1000 units. Suppose your load. Is it okay? In a typical planning horizon. So what is throughput time? That means you start producing the first unit. Okay. First unit you note down, and then the time you start with the first unit, and it goes through several stages, a number of stages, and you keep on feeding. Is it okay? The raw materials as per the requirements for 1000 units. That means the starting time of the first unit, okay, at the first stage, and the ending time of the last unit from the nth stage. Getting my point? So that means I will say that this is the total time I spent in the system for producing 1000 units. Is it clear? So the starting time and ending time. Now this when you talk about this the total time, that means this total time are grouped under say the 4 categories. What are those? The first one is the setup time. Setup is required. What is the next one? Once the setup is ready, is it okay? Now you go for the processing. So the processing. Then, suppose you process at one stage, it has to be transferred to the next stage. So what sort of systems you have? You have the material handling systems of different types. Okay, depending on the type of material you use or the type of the semi-finished parts you have. Okay. So you have varieties of material handling systems. Okay. Now, so next one is the transfer time. Okay. Mainly the material handling system from one stage to another. What is the fourth one? Fourth one is that waiting time or the queuing time. It's not that it's a discrete manufacturing systems what we are talking about. I'm not talking about a chemical process. Getting my point? Continuous processing. We're talking about the batch production. And what do you find? There are 3 kinds of manufacturing systems we have. At one extreme, you have the job shop, and other extreme, you have the continuous processing, and and you have the batch production. So what do you find? That the 70 to 80% of the products which you find over here getting produced, they're coming from the batch production system. Okay, the repetitive manufacturing, discrete manufacturing. So we are essentially the focusing on the batch production, repetitive manufacturing. So next one is the waiting or queuing time. Okay. Now you tell me that out of these 4 the time elements, which one is the value adding? Which one is the value adding, and which one is the non-value adding? Setup. Is it a value adding or non-value adding? Huh? So setup is non-value, processing is value adding, transfer is non-value adding, and so also the waiting or the queuing. So your the primary endeavor, your attempt, you must make an attempt to reduce the setup. Is it okay? Like in some cases, the Japanese organizations, they have made one particular technique very, very popular as far as reducing the setup is concerned. It is called single minute exchange of dies. You must be aware of. This is referred to as SMED. So you must go through what is SMED. the reduction is like this. Initially they have found that the setup time it could be as high as 700 minutes. Now the change, the setup, improvement in such a way, the 700 minutes now it has become 70 minutes. Are you getting my point? It's not that just you reduce it from 700 to say 500. So that's not called SMED. When significant change, very, very significant change. Are you getting my point? That means in maybe just with 10% of the original time you spend, you can get the setup. Is it okay? So there are many ways you can identify those activities like internal setup, external setup and all. So I suggest that you go through all this one. So when you talk about JIT based manufacturing system, so this is very, very important. Zero setup. Your goal is zero. It's clear. So later on, the time permitting, I may discuss these aspects also and how these are related to the quality. It's clear. So the measurement, the performance measurement is the cost of quality. Is it okay? That means you have established a quality management systems. You must have a mechanism, with which you will be able to estimate the cost of quality. Is it okay? Right? And you assess the cost of quality, and you must take appropriate means, appropriate measures to reduce the cost of quality. It's clear all the time. Now he has talked about quality improvement. Again, he says the 14-step plan, like the management commitment is an important factor. Quality improvement team. Is it okay? Like we say the project team is to be created. The problems you are handling today, most of the problems are having multiple dimensions. Is it okay? So, always you go for creating quality improvement team, quality measurement, cost of quality evaluation, I have already mentioned, quality awareness, quality awareness programs. The different kinds of the programs you can initiate. Is it okay? Some of these programs are branded as awareness programs. So 1 day duration or half a day duration. Is it okay? And you initiate such program. You for all the employees of an organizations, 1 day or half a day awareness program on quality for all the employees at all levels. Is it okay? Then the corrective action, ad hoc committee for the zero defects programs. Is it okay? Committees to be created. Supervisor training is very, very important. In fact, many a time, what we do not face any problems with the workers or with the middle level managers or the executives. In majority of the cases, we face problems in motivating the supervisors. Is it okay? So all sorts of the Japanese tools and techniques what they have implemented, Japanese organizations, primarily directed to motivate the supervisor staff, right? So ZD day, so you have to declare that these days like the safety day and all those. Goal setting, error cause removal. I have already mentioned that the symptom is fine, but you have to know what are the causes. So for that, there are different tools and techniques you can use, the data presentation tools. Then recognition is very important. In fact, is it okay? Means I must know that who has actually contributed, whatever may be his designation. Everyone must be treated as a human being in this context. Many a time it doesn't happen. In fact, is it okay? Maybe someone has contributed and someone else is taking credit, and he is taking the prize in front of all others, right? Right. This happens. This must not be accepted. It's clear. So the recognition, quality council, and do it over again. That means you say that okay, I have done it. The quality, the system has been created. Now you remain satisfied, and so this should not be that issue. That means from one level to another you have proceeded. So now once you reach that level, okay, now you have to set another target. That means the cycle continues. So, Juran believes that management has to adopt a unified approach to quality. The Juran quality is defined as fitness for use. We know that it is from the user's perspective. That is the definition of quality. Focus is needs of the customers. I must know what are the needs of the customers. He proposes a universal way of thinking about quality that he calls quality trilogy. So, it has got 3 phases. The first one is the quality planning, the next one is quality control, and the third one is the quality improvement. So, he says this is a quality trilogy. So, 3 basic steps to progress: achieve structured improvements on a continual basis, if not continuous, combined with dedication and sense of urgency. Is it okay? Dedication and sense of urgency, those are the key words. Establish an extensive training program, establish commitment and leadership on the part of higher management. These points we have been always emphasizing. Okay. So, he has also proposed 10 steps for quality improvement. First one is the awareness, second one is the setting goals, third one is the organization, right? You have set the goals, but how to organize to meet the goals that have been set. Provide training. Is it okay? That means everyone is working following a certain norms. Now, it may so happen that the norms you need to change. So, obviously, you have to train them up. Implement projects aimed at solving problems. That is already known to you. Report progress, that means constant monitoring has to be there. Give recognition. There are some, you has also said that all those philosophers in the field of quality, they have mentioned about the recognition. This is most important. Communicate results, right? That means the feedback. Okay, I have done something, right, and results have obtained, and you must give him a feedback. Keep score, maintain momentum by building improvements into the company's regular systems. It's clear. That means the quality management systems is a part of the total systems of the organization. So, this is the way we look at. That means the cost of quality aside, the quality planning. There are several activities you carry out under quality planning. Then you set the goals. That means this is a quality control during operations. Okay. So, now there is a sporadic spike. That means there will be variations. So, these causes should be known. That means there must be some assignable. You know what is an assignable cause. Okay. You know what is the common cause, the random causes, and all those. So, the chance causes, and you have heard this term, no? The chance causes, assignable causes, and all those. So, whenever you find the sporadic spike, that means there must be an assignable cause. So, you must be able to detect that cause. So, ultimately from one level you set the next level. That means suppose your target is say 5%. Is it okay? So, plus minus say 5%. You achieve this, right? Okay. So, your system is sufficiently under control. Now, what you say that okay, I will improve from 5% plus minus 5% to plus minus say 1%, plus minus 1%. New target. Is it okay? And for achieving the new target, what sort of the actions you have to take? Is it okay? So, again you go for the planning, right? So, what is required to achieve this one? Whether with the same machinery you can achieve this the target or not. Are you getting my point? So, or the improvements are required, or in the form of the better settings, or the better toolings. Okay. So, all sorts of the actions you must be able to make you must be able to plan, right? And then you go for the new zone of quality control. So, the first quality planning, and then you go for quality control, and then only you may go for quality improvement. Is it okay? Many a time what happens that in a hurry you try to improve. Is it okay? but without bothering about the assessing the present situation. Is it clear? Okay, so if your systems cannot achieve a target of plus minus 5%, if you are insisted on that, why don't you achieve plus minus say 1%? Is it okay? So you have to follow these steps. Okay, there's no other way. That you cannot skip quality control, right? So this is quality trilogy process. These all details are here. So in the quality planning phase, what do you try to do? Identify the customers, both external and internal. We have already defined what is an internal customer, what is an external customer. Determine customer needs, develop product features that respond to customer needs. Okay, so what process you have? That is a design process actually. Establish quality goals that meet the needs of the customers and suppliers alike, and do so at a minimum combined cost. It's clear? That means many a time what you do, that means the design at what cost. It's very important in fact. So the design level you need to select, right? So as I have already told you, the difference between the value and cost should be maximized. Is it okay? Develop a process that can produce the needed product features. Okay, and prove process capability. These are just as a general. In general, we have explained this one. Prove process capability. What is process capability? Given a process. So process capability means ability to produce, okay, as per the specifications or the standards. This is just one liner, one sentence. Okay, you are given a machine. You are supposed to produce one component. Suppose the operation is turning, okay, as per the specifications. So you just go for producing 1000 units. Is it okay? And then you check that to what extent you are able to conforming to the specifications, right? So whether say the outer dia or inner dia, the corresponding quality characteristics you must be able to identify. Is clear? And then you say, okay, so almost 100% say the non-conforming, say the conforming output I produce, not non-conforming, conforming output I produce. So you say that with respect to this particular component, with respect to this process, right, with respect to these specifications or the standards, my process capability is 100%. Is it clear? So this under those set of conditions you must be able to specify. You cannot say that the process capability is 100%, and then you are unable to identify the conditions. Under which conditions? Is it okay? For what kind of quality characteristics? For what sort of standards? For what sort of materials? And for which kind of machine? Right? You were making the statement. Okay, so this is very important. Quality control, choose control subjects, product characteristics, all know in fact. Is it okay? Quality control already you are studying in fact. Choose units of measurement, then establish measurements, establish standards of performance, measure actual performance, interpret the difference, actual versus the standard. Is it okay? There will be always some variations. Take actions on the difference. Is it okay? If suppose you assume that this variation is natural, you are not going to take any action. But if you find that the difference is really significant and you assume that there exists some kind of assignable cause, so what you try to do? That means you try to identify the assignable cause and you find one or more and you have to take some corrective actions so that these causes are removed. Is it okay? That is the whole exercise you do with the philosophy of do it right first time, all the time, and quality is job number one. Is it okay? So it's an online real-time control, the systems you have to develop. Is it okay? So this is quality control. What about quality improvement? Prove the need for improvement, address chronic problems. Chronic. It's clear. What is the chronic problem? So you must be able to identify what are the chronic problems. Is it okay? So okay, and then identify specific projects for improvement. Pareto analysis, sporadic and chronic problems. That means the chronic means it is inbuilt. Okay, you are living with these problems. Is it okay? And so now what you have to do, that means for improvement purpose, you must know what are those chronic problems and to what extent these chronic problems can be removed. Is it okay? So a new project is to be initiated. So many a time. That means suppose you say I have achieved maximum from the existing resource, or say from a particular machine. What you need to do, that means in order to improve, okay, now you need to change the technology part. Is it okay? So those sort of decisions you have to take. That means say right now you are using say second generation system. Why don't you adopt third generation? Or if it is third generation, why don't you adopt fourth generation one? Is it okay? So you have to make a judicious choice. This. So organize to guide the projects, organize for diagnosis, for discovery of causes, find the causes. One particular, the tool you can use, that is cause and effect diagrams. Okay, or Ishikawa diagram. Provide remedies, most difficult step. Is it okay? Prove that remedies are effective under operating conditions. Provide control mechanisms to hold the gains. That means always we are insisting on, okay, you are taking some actions, but are you in a position to create the system? Is it okay? Okay, so I will take it up, the other issues also one by one slowly. So I stop here and we will break for 15 minutes. Okay, then again we'll start the next lecture sessions around 10:30. Okay, fine. If you have any questions, one or two questions, you may raise. The last class you attended? Okay, the quality assurance, I will just examples. Like say, the quality control means that do it right first time. That means monitoring is required. Constant monitoring is required. And what you say, online real time monitoring. In the quality assurance, that means this monitoring is not required. You say yes, I will be producing the 100 the parts, okay, 100 parts, 100 units of a part, and I'll tell you that no inspection is required, no control is required, and I am guaranteeing you that all these 100 consecutive parts or the units will be conforming. Getting my point? That sort of assurance. There are many such systems. That means, but I cannot say that whether 100 and the first part, whether that will be conforming or not. So that is essentially quality assurance. Is it okay? Means without controlling, without inspection, I set the conditions of the machines in such a way that I declare that consecutive this number of parts, okay, will be produced as per the specifications. There will be no rejections. Is clear? So many a time you have automated systems like 100%, say 100% inspection, automated systems, like say like the tablets you produce, baby food you produce. It's clear? So it's when the production rate could be per minute 60 units or 120 units, or maybe say 360 units per minute. Very, very fast. Each and every unit is to be inspected. You're getting my point? You cannot afford to have the sampling inspection. So now you say that I have created a system, okay, 10,000 consecutive the baby foods will all be conforming, but beyond 10,000 I cannot assure you. That is the systems I have created. Next year maybe I will say that we are changing the system as an improvement initiative. We say 100,000 units. We are setting the target. We don't need any inspection. Getting my point? So from one level of the assurance, you are going to another level of assurance. Getting my point? So for that, you need to use different kinds of the technologies, in fact. And even if there is some defect, immediately, that defect is to be, taken care of, or that particular the defective unit must be taken out from the system. Is it okay? Automated systems. Yeah, many. Like say, there are many kinds of technologies you can use. We have used, for our PhD level research work. That means automated systems, image processing technology. There are many technologies available for that. So what we are trying to do for those, the mass produced items, mass production, where the sampling inspection is just not acceptable, right? So why don't you go for, say, automated systems, non-contact automated systems? Is it okay? Okay. Thank you.
পকেটে থাকে অসুবিধা হবে পকেটে হলে আমি ঘুরতে পারবো একদম 100% স্যার morning good morning so we will continue with DOE design of experiments and our book is Montgomery's design and analysis of experiment. Okay, so first class we have given some ideas, some concepts. For example, what is experiment, what is design of experiment, what replication, randomization, blocking, and also I have given you some examples saying that what is experiment, and then finally we have discussed a process model where we basically talk about something like this, that inputs x, then z, and then y inputs, and we talk about that function of y is a function of x and z, and if we now you have to play our ultimate aim of all experiments is to know about this. Y is function of x in different ways. For example, that if what is the change in suppose delta y, how this change, how it will be affected by x, affected by z, affected by the interaction of different x parameters, something like this. And what I have understood after that Professor MKT also taught you some amount of DOE part. Primarily he talked about one-way ANOVA. Am I correct? Yes or no? So and also he has given you some test called F test. Yes or no? Okay. So today what I will do, I will start with one-way ANOVA and then I will ask you to solve something, and then followed by two-way ANOVA if possible. Getting me? Now I think this particular example he has given to you. Yes or no? Good then. Now how many of you are in a position to explain the right hand side this plot? This is box plot. So what are the questions given in the left side of the box plot? Does changing the power change the mean each rate? Okay. So that means what is the factor here? Factor is power. So in fact how many values are there? 4 values, 4 treatment values. So power is factor, which is also known as treatment. Okay. So this power has 4 levels of treatment. One is 160, 180, 200 and 220. Obviously these are continuous values. Okay. Other way we can say this is level 1, level 2, level 3, level 4, something like this. So with respect to this example, how many replications are there against each of the level? 5 replications are there. Okay. So 5 replications, 4 labels, there are 20 total observations. Okay. So that means n equal to 20, total observation n 20 and replication small n is 5. Okay. Now question comes that does changing the power change the mean each rate? Okay. So what is average here, this side? So when you fix the power at 160 watt, the mean each rate is 551.2 units. Similarly, when you fix to 180 watt, it is 587 and so on. The question is whether these are different or not. Getting me? You want to know whether 551 is different from 581, 87.4, whether 587.4 is different from 625.4 or from 707.0, these values. Obviously, you will say obviously these are different. Okay. So, there are two ways of thinking. If you think from the numeral values, obviously they are different, but if you think from the statistical sense, they may not be different. Getting me? So, that is why the question is, does changing the power change the mean H rate? If you can prove that yes, these average values are different, then your question is answered in the sense that power has effect on mean H rate. Okay. Then second question is there an optimum level for power? What do you want? You want mean H rate to be maximized or to be minimized? Maximized. If it is maximized, then you want to set the power somewhere, not necessarily 220. Okay, so you want to set this. That is why this is there any optimum level of power? What is that level of power which gives you the optimum values for the mean H rate? So, you want to test the two. The first one can be tested by ANOVA, second one can be tested by post hoc also for the first one, post hoc analysis. Second one can be tested through response surface methodology, and so optimization in this DOE case will be tested through response surface methodology, very popular in quality domain, RSM, more popular in the name RSM. Okay. So, this is a optimization problem in the second case. As I told you, the process optimization. What is process optimization? Where to set the process parameters so that the optimum output you will get. Fine. Now, if I ask you, are you in a position to answer the first question? Do you know ANOVA? I think yes, because 1 hour lecture was given to you. Suppose I am asking you, you solve this one and tell me what is your answer. Can you do? How many yes, how many no's? Can be done? Okay. Then I have few questions. What is step 1? It is a hypothesis testing problem, yes or no? Okay. What is your null hypothesis here? Means are equal. So, that means there are 4 levels. So, mu 1 equal to mu 2 equal to mu 3 equal to mu 4. That is what you are saying. All means are equal, that equal to maybe mu. Okay. What is your alternate hypothesis? What is not equal? So, mu j not equal to mu k for at least one j k combination. Obviously, j not equal to k. This is the case. So, why are you not using t test here? Because all of you know
more than 2 samples,
more than 2 means. So, equality, this is a hypothesis test for equality of means. That basically in statistics sense it is population means. Here this population is nothing but the treatment levels. Different treatment level is different population. Okay. So, the usual procedure is, okay, first is hypothesis. Okay. What is the mathematics behind it? What is the mathematical model? Anybody? Because I know that you know this. I am just seeing that whether you are able to tell or not. F test is the test only. Suppose here what you are trying to say, that you are trying to, you take any of the values here, any of the values in this table. Okay. Will it be affected by the power? That type of model I am asking about, some kind of mathematical model. For example, if I consider I the labels, treatment labels, okay, and obviously here I equal to 1, 2, 3 and 4 because there are only 4 labels. So, it can go up to A level. In this case A equal to 4. What is J? J, let J equal to 1, 2, 3 up to N. In this case N equal to 5. Okay. So, any of the observation can be denoted by Yij or not. Okay. Suppose I want a model, because I told you y is function of x, beginning I started saying this. So, if I want to write this, how can I write this? Okay. In terms of here factor, you are getting me? Factor basically, this power is the factor here. So, power has different level. So, you do some kind of intelligence here. What is this intelligence? Suppose I am writing this one as y bar, okay, or the just let me see what way they have. Notation is very important. Okay, notation is I am writing this as y dot dot bar, okay, because I want to follow the same notation. You can write y bar also, no problem. Okay. Suppose this one I write plus, I write suppose y I dot bar, okay, then I write minus y dot dot bar. So, y dot double dot bar plus and minus is cancelling out, yes. Then plus I want to write y I j minus y I dot bar. Tell me left hand side right hand side equal or not? Yes. Y dot dot bar and y dot dot bar, this cancelled out. The I dot bar is also cancelled out. Y I j equal to y I j. Okay. So, this is known as partitioning the observations. I am talking about partitioning the observations. What is your observations here? Y I j. So, if you change I and j, all kind of observation, every observations you will be able to find out, fine, and that is the starting point of ANOVA. Now, what is this one? Given this 5 into 20 data points, if you sum them and take the average, that is the grand average, all levels, all replications together and putting the average, this is known as grand average. Okay. Now, what is this one? As I told you, I equal to 1 to A, suppose I equal to 1, then this is the average of the first row, first level. So, that means this is treatment average, yes, treatment average. If I change I1 to A, that will treatment will level will change. So, it is treatment average. Okay. Again this one is grand average, same thing other one. Okay. Now, what is the total this total quantity? That means treatment average minus grand average. Now, you come to hypothesis H0. What you are saying? You are saying all means are equal. Here it is in the sample domain, that is why you are writing average. In the population domain you write mean. Actually, population means something unknown things, basically you do not know the totality. So, you are assuming parameters. So, these are parameters mu1, mu2. In the sample domain you have data, you collected the values, these are all random variable, these are known as sample statistic. So, in statistics these two are very important, population, parameter, sample statistics. That sense you have to understand here. I am sorry. Hello, I am taking a class. Okay. একটু হ্যাঁ ক্লাস নিচ্ছি পরে হ্যাঁ okay. So now if all means are equal, then the grand mean is also equal to all means, yes or no? This is equal, this is this plus this plus this plus this by nothing but the same thing, because all are equal. Then what will happen here? It will become 0. That's why null hypothesis is saying that there is no difference. Now say that there is difference. yi dot bar is not equal to y double dot. That means this is nothing but the treatment effect. Okay. So what you will be writing then? You write yij equal to y dot dot bar this, plus if I write this is tau I cap. I think they are using tau I only. Okay, let me write tau I cap. Okay, so that means what is this tau I? Tau stands for treatment effect. Then what is this treatment effect? Treatment effect is nothing but here in one way never case level average minus grand average. You have to estimate, getting me? So then come to the third last one. What is this? Error. Yes, error. See, ultimately you have taken n equal to 5, some kind of experiment you have done, you got this. If you do another experiment, you will be getting something else also. So no, this model, it is impossible for a model to capture all the things. There will be some kind of errors. So this one is error, last one is error. So you can write this is nothing but error epsilon ij, each individual errors. Okay. So your model now let this one, instead of writing y this dot 0 0 this one, this also you write in terms of cap, because from the estimate you are getting. Okay. So this is a sample ANOVA model. Okay. Now if you talk about in the population domain, what you write? So that means if this way you write y bar and all those things, and this one also the estimate, because this ultimately this will match because of everything you have considered here. So in the population domain, yij you will write equal to mu plus tau I plus epsilon ij. This is your one way ANOVA. Okay, fine. Now if H0 is mu1 equal to mu2, like this equal to mu a equal to mu, then what will be tau 1 equal to 0. So alternatively H0 can be written like this, tau I equal to 0. We started with H0 all means are equal. Now we are finally saying that effect is 0, because if h mu1 equal to mu2 equal to mu n, then tau 1 equal to 0, tau 2 equal to 0. So tau I equal to 0 for all I equal to 1 to a, and obviously h1 will be tau I not equal to 0 for at least one I, at least one treatment level. Okay. So in ANOVA what you do? You require to estimate tau I. This is the first part. Okay. Now how do you estimate? So tell me, how do you estimate all those things? Very simple. Tau I is nothing but the level average minus this. Okay, this is first. Fine, fantastic. For example, go back here, your tau 1 is 551, a grand average, you find out grand average. I have to see that whether it is there or not. Grand average, no, in my slide it is not there, no problem. So all the 4 you add and divided by 4, that will be, because n equal to equal here, so you will be getting grand average here. Average of averages, that is grand average. 551 minus this, that will be treatment effect on level 1, level 2, level 3, level 4, like this. Understood? Half done, something is done. Okay, now come to the contribution. You see the model. Second one is contribution. What is contribution? Actually, what I am saying, that if your contribution is large, then it will be statistically significant. If your contribution is less, then it will not be statistically significant. What is this contribution in particular in this case? In this case, contribution is that that averages are different from this. What I mean? Let me write down something like this type of things. For example, this is my this is the mean equal to mu equal to, let it be, this is mu, let it be mu, or grand mean. This is my grand mean. Now I am finding out difference. Suppose first difference, level difference, that means this minus, suppose your first level mean is here. So that is, this is your mu 1. Suppose second level mean is here, this is mu 2. Third level mean is here, this is mu 3. Fourth level mean is suppose here, here, this is mu 4. So this tau 1 is this much, tau 2 is 3 is this much, tau 2 is this much, and tau 4 is this much. The interesting thing here is that sum of positive and equal to sum of negative. That means what I am going to say, sum of tau I is equal to 0, because what you are doing, you have the same thing, you are just saying that what is at the higher level, what is the lower level, and then the total is 0. So this is another important concept in ANOVA. Okay, for one way ANOVA, multi-way ANOVA, that will be different. I equal to 1 to a, tau I equal to 0. Okay. So contribution means what you want to know, that this difference is significant or not. This difference is significant or not, that we will do. What ANOVA does here, I hope that you have gone through, even I am repeating, that ANOVA basically intelligently, you see that ANOVA partitioned this. You do one thing, you just some kind of manipulation you make here. What is that manipulation? I am writing yij minus y dot dot bar, that means this portion grand average take to the left hand side, and then what is there, yi dot bar minus y double dot bar plus, put under bracket, plus yij minus yi dot bar another bracket. Okay. So what is this? This is nothing but deviations. Please remember, this is the each of the observations is, what is the deviation of each of the observation from grand mean or grand average. Here you use the word average. Here each of the treatment level deviation from grand average. Here is each of the observations deviation from level average. So all are basically deviations. Okay, differences. So now you do one thing, you square it. Okay, what will happen? This square. Okay, so you can write this one, yi dot bar minus yi double dot bar, this first square. then yij minus yi dot bar the second square plus 2 yi dot bar minus y double dot bar into yij minus yi dot. It's okay, but this is for only one observation. This is for one observation. How many observations you have? 20 observations are there. So you have to consider the 20 observation case. So what you require to do, you put, okay, so first you put j equal to 1 to n, that means all replications are taken into consideration. So here also take j equal to 1 to n. So here also j equal to n, here also j equal to 1 to n, here also j equal to 1 to n. So that means what happened, you have taken now one row into consideration. Take the all the rows. So another level, you add another level, I equal to 1 to a, 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 I equal to 1 to a. Okay. So that means now all the observations are taken into consideration. So when you talk about contribution, not from single observation, all observation taken together, what is the contribution? Okay. So left hand side is becoming basically the deviation squares from the grand mean for all the observations. What is this? Total variations. Okay, and I hope that you have already seen this one, the concept called SST. Let me see again the notation, the way they are using SS small t here I have used, anyhow small all those things. Now what is this one? This is treatment contribution. So SS treatment, because level average minus grand average the square. What about this one? SSE. Oh, what is this? You have gone through ANOVA. I am asking that's why. Hello? Here nothing but this quantity will become 0. Why? Suppose you see ultimately here there is no j. So this one I can write 2. So j part is taken out, I equal to 1 to a. So yi dot bar minus y double dot bar. Then suppose I can write like this. Then this portion is having jth component. So j equal to 1 to n yij minus yi dot. This what will happen if you sum this one? What is the mean value? Sum of yij by n small n. So what is this one? This one is again mean value. So you do little more manipulation, very simple one. This will be nothing but n mu minus n mu or n average. So that will become 0, this 0. So that is the another intelligent way of partitioning the total variability into two components here. One is treatment variability, another one is error variability. Fine. So our things become simpler now, that SST equal to SS treatment plus SS error. Okay. So, whatever variability is there, that variability in one way and ANOVA case, this variability can be partitioned into two part, one is treatment, another one is error. What will happen if treatment SS treatment is very small compared to SS error? Effect is no effect, overall no effect is there. So, obviously your design of experiment should be such that, and you will choose the factors in such a manner, and also you choose the level in such a manner that you find out that the effect, if the factor is important, it will have effect. If you do the design experimental design correctly, that effect will be understood, or that effect will be measured. So, if I consider those things were done perfectly, then the treatment effect will be much more compared to SSE. Okay? That part you know, because I think that slide you are shown that that is MSE, all those things are there. Okay? So, treatment, I think now you know how to compute the treatment. Okay? So, given the data set, if I ask you find out SS treatment, are you in a position to find out? What you will do? You will simply use this, you will use what is the treatment, this one, J is not there, so J equal to 1 to N into this will be there. Okay. So, this is a tedious process, in the sense it takes more time. So, that is why what I will give you one simple computational scheme here for treatment. For computation for SST will be like this. Okay. I equal to 1 to A, J equal to 1 to N, Y I J square minus Y double dot, that is the total, gross total, by capital N. This is a better way of calculation. It will help you. It is manually computed. Then similarly, SS treatment also you write down. How write? 1 by N sum total of I equal to 1 to A, Y I dot square minus Y double dot square by N. So, the table given to you, the data table given to you, there are 20 data points. For every data you square it, then sum, that will be this one, then divided by 20, this part you will get. Every row sum is there, square it, this one will be, you will be getting. So, ultimately you will be in a position to calculate these two. Then how do you calculate SSE? You can use the formula, but not required, because SST is SS treatment. Okay, this is over. But your work is complete or not? No, sure. Then what do you should do? How do? Mean sum of square degrees of freedom. Okay. तो चलो mean sum of square degrees of freedom देखो. This it is clearly written here. You have any query? Okay. Actually, what is going to happen here? So, when you are computing SST, if you see the formula, how many degrees of freedom you have? N minus 1. When you compute this one, A minus 1, because A is the number of labels. So, again this also follows the partitioning, that N minus 1 will be A minus 1 plus something which will ultimately lead to this, that means N minus A. Okay. So, then go to the table, this table. You just see the table here. in the table that this is very important table for all of you, ANOVA table, that between treatments, which is basically SS treatment, error or within treatment, this is SSE, and total is SST, and this is the formula, and these are the degrees of freedom. Now, your actually aim is that you want an experiment to be conducted in such a manner that error within for every level will be minimized, but the difference between level will be maximized. So, the difference if maximized, that will be considered in the SS treatment, and error is minimized, that will be considered in SS error. So, as a result, we always want more SS values for SS treatment in comparison to this. So, that is why you are creating a ratio which is known as MS treatment. What is MS treatment here? MS treatment is SS treatment by SS error. Okay. And degrees of freedom are given. Now, sorry, I am sorry, MS treatment is SS treatment by degrees of freedom, MS error is SS treatment by degrees of freedom, and you are creating a ratio of these two variables by computing F0 MS treatment by MS error. This one follows F distribution. Okay. So, why it will follow F distribution? Why not Z distribution? Why not chi-square distribution? Why not any other distribution? No, not like this, but this will not be taught to you now, because it requires your chapter 2 of Montgomery. Okay. So, different variables depending on the properties of the variable. So, there are different ways of doing things. So, ultimately that will help you in understanding that under what condition you will go for T, what condition you will go for F, and what condition you will go for some other things. Okay. So, fine. So, MS treatment now F0, if you compute F0 and if you find, and there will be a threshold value, and based on this threshold value your computed value, if it is more than threshold value, what will happen? Your computed value somewhere here, threshold value for 5% probability level it is here, for 0% probability level it is here. So, as the computed value is far away from the threshold value, any one you take, so you are saying that there is level differences, otherwise no. Okay. So, this also the fundamental is expected that you know that why this way things are happening. This is a distribution when null hypothesis is true, and you are getting, that means it is expected that the computed value should be within the distribution, but computed value is far beyond the distribution, the shape of the distribution within the curve. So, that means it is not from this, that means H0 is false. Okay. Then few more things which perhaps was not told to you in last class. Every model has certain, based on certain assumptions. What are the assumptions of ANOVA? Well, I am repeating the same thing. With a simple purpose I am repeating, so that you can reproduce. What are the assumption of ANOVA? Not mean error is 0, to that is almost obvious. Okay. So, one of first assumption is normality of the error terms. Okay. Second one is constant variance, or actually in a regression, I think Professor Mukherjee, Professor Mitra told you, the Mitra, assumptions of regression. This is also a regression, actually ANOVA is also similar to regression, only here discrete values are there in the dependent case, and in regression independent case, in regression independent variable are either continuous or discrete. When it is this categorical, go for dummy case. Anyhow, so same thing will apply here. Normality. Second one is constant variance. Third one is interdependence. Okay, and fourth one is definitely that have the fit of the right model. This is not assumption. Later we will check the okay. So we want to, for ANOVA model, normality is to be checked. Normality of errors, homoscedasticity to be checked, which is basically known as constant variance. Okay. Third one, you have to check that independence, that is basically IID, all of you know, independent and identically distributed. These are all related to errors. Okay. Another one is uncorrelation. No one, the observation should not be correlated. So that is uncorrelated errors, error terms or errors or error terms. Please note that these things, if it is not satisfied, your F test, what you have done, not correct. F test is based on certain assumptions again. One of the assumption in F test also that this IID uncorrelated and all those and all those things, and in the basic level primary that error variables are also normality, because you have manipulated with the data and finally gone to the F level. So how do you test normality? Okay, there is one thing called PP plot, probability plot. What we will give you something like this. You will be getting a probability graph paper. This side is the normal probability, this side is the residuals. Okay. So once you have done the experiment, all the estimated error values, these are known as residuals. So residuals you arrange from lowest to highest. This is what is lowest to highest, and it is expected that this residual follow normal distribution. So then if the observed values are normally distributed, and if we find out for each of the quantile the theoretical value from normal distribution, they must match, and as a result they will resemble, when you plot, they will resemble a straight line. I am repeating, if errors are normally distributed, then for every quantiles, every point here, every quantile values, if I take the theoretical value from, generate the normal values from the normal distribution with the appropriate mean and standard deviation, then what will happen, whatever values you will get, that will be 1-to-1 correlated with this one. But as these are all sample data, you cannot get exact matchings, there will be little error here and there, but ultimately overall this will be a straight line. Okay. So there are many other way to do this, but probability plot is the best one. There is quantile plot or QQ plot is also there. Okay. So even there is simple Z test is there. So you take the largest residual and see that value is more than 3 sigma within that, beyond the 3 sigma level or not. If it is that, reject is at 0.027%, 0.27 percentage. 5 point case, I think 1.96. This is the case. Okay. Now if normality is satisfied, you are happy. Come to the second one. Second one is homoscedasticity. The simple thing here, when you have data, Suppose these are all observations, x values, factor values. And this side what you are getting, for every factor you are getting the response. Setting factor, in this value some response, in this value some response, in this value some response, something like this. Suppose if I say this is my 160, this is to 180, this is 200, and this one is another one, this is 220, and if you plot the values in 160, 575 to minimum value 530, so somewhere here if I say this is 530 and 575 is maximum, if I say it is 570 maximum, so in between these values are there. Similarly for the other one also if it is increasing, this is increasing, so that means from here to here maybe. Third one is further increasing, maybe from here to here. Fourth one is also further increasing, maybe here to here. 5 points are there, na? So let it be like this. I don't know whether this is happening or not, but I think this will happen. Now for every factor value you have multiple number of y's. So this also follows a distribution, and as per our assumption this will follow normal distribution. So now average will be somewhere here. Here when you are talking about average of the first one, maybe average of the second one is somewhere here, average of the third one is somewhere here, average of the fourth one is somewhere here, level average. What you are doing, suppose you draw a line like this, regression line. Then if you see this one, maybe your error variance is something like this. This is normally distributed. Actually here I think in this data it is like this, but it may so happen that you find out that in the first level this is like this, error distribution is like this, or y values like this. Second level it is like this, third level it is like this, fourth level like this. What is happening then? It is basically going like this, funneling right. It may be other way around also, it can happen like this. Here it is very big, here it is little more less, here it is further less, here it is like this. Then if you plot, it will be something like this. So funneling left, funneling right. So this will happen if the variance are not equal across all factor values. This is another assumption. Whatever may be your factor values, y's variability must be equal. That is constant variance. Now how do you test it? You will not test with the y values, you will test with the error values. So what you will do then with the error values? You will plot residual versus predicted values. Okay, what is the predicted one? What will be the predicted one? Yes. Here if you want to say predicted, then ultimately this is y predicted, you only consider this portion, error part will not be there. Y predicted is this plus this, because the grand average plus treatment effect, this will not be there. So what you are doing then, this portion, this one and this one you are plotting here. Residual is this right one and this one you are plotting here. Now this portion, this y paid, this one, you see all the average values, this is basically systematic part of the data. So from this diagram, if you take the systematic part out, then the unsystematic part will be where? Will be here in the error. That is what is the concept. So that means in the residual that unsystematic part will be there, and as a result predicted versus residual also will be either it will exhibit like this, the funneling up or right or funneling left. If this happens, that means violation of constant error variance, and it is a major violation. Your findings cannot be interpreted in practice, because that is the issue, and this is true for regression also. Even in the regression, what are the test I am talking about, the checks, these are all applicable to regression also. Okay. What are the third one? IID, na? Independence. Independence, what will happen? You have observed, every observation put the values, and they should be random. That is run order of or time, that means first observation, second, in what order you have done the experiment over time, that you put first to 20, and residual values are known to you, already computed, put here. If you find out the data exhibit randomness, then it is independent. Here also data exhibit randomness, no funneling left to right, left or right, then that is constant variance. Okay. So this has independence, as well as if there is correlation, it will also show. Suppose second observation is biased by the first one, then you are basically what you are doing? You are basically changing this accordingly. Oh, first observation should be 55, but it 45 aa gaya. Next one you are doing like this. I can tell you that experiment in the lab. Usually I have seen one person was done experiment that suppose some physical laws to be follows, and he has a good curve, then curve first fit the curve, get the values, and see in the experiment whether coming or not, accordingly twist one case. And many times it happens because of you are in a hurry, submit karna hoga. To find classroom teaching purpose, actually you know the procedure fine, but when you are talking about you are actually contributing in the design of the real world system, mat kijiye, karega to control ho jayega. Okay. So all those assumptions must be satisfied. Whenever you do ANOVA, regression or any, it is a simple ANOVA, one way ANOVA, two way ANOVA, multi way ANOVA, multivariate ANOVA, that is known as MANOVA, or regression, simple, multiple, where, or any other model assumptions are very, very important. Checking is very, very important. If you do not do this, cannot relate to practice. Very simple way. Okay, so that means what? How much you know now? You know that yes, there is a procedure. By that procedure, you are in a position to tell whether the null hypothesis is accepted or rejected. And suppose null hypothesis is rejected, there is factor effects. You are happy. Then you are saying, okay, my model is fit or not, my model is good or not. Through test you have done it. Your test results are reasonably accurate, saying that the model is fit. Next question comes, okay, when you talk about 4 means altogether, then you don't know which means are different. Getting me? There are 4 means. In our example, how many 2-way comparison possible? 4C2, 6 2-way comparison possible. My overall my null hypothesis is accepted against the alternate hypothesis, at least one pair is different. So which pair is different? How do you know? What do you do then? Two keys test. Okay, fine. So there are some tests, and he knows this. Obviously, one of them is 2 key. KUI na? 2 keys test. Fisher test is there also. Fisher test. That is LCD probably. LSD. Fisher's LSD. Least square deviation. Least significant difference. That least significant difference test as a Taki test. There are some more tests also. Okay. So how do you do those things? They will basically here in the Fisher case, t distribution is followed, and in the Tukey test also some kind of distribution is generated and that is followed. So, that means every pair will be considered. My question to you, if finally I have to do this all those things, that comparison, same comparison, one average 1 to average 2 or mean level 1 mean to level 2 mean, then first time I can do this, why I will go for so much of drama? You are getting me? Ultimately 6 comparisons you are making out of comparisons, and when you are comparing that tau 1 versus tau 2, this is nothing but either Tukey or LCD, you are doing some kind of t-test. So, they पहले t-test कर लो, let it be done and then say okay, these are different. So, where is the difference? Getting me? The difference is there. If you see the t-test 2 population mean test formula vis-a-vis in ANOVA, the Fisher LSD or Tukey test, the formula will use. Okay. So, in this case the MSE, that is mean square error, which will be taken as the standard deviation variance part. Okay. So, that means the overall, the gross thing, the totality is taken into consideration in some of the parameters. So, the inflation or other way around, whatever is there, that is taken care of in these formulations. Okay, it is not the traditional t-test what you are doing, in the formulation itself that issue is taken into consideration. So, as a result, it is expected and it is suggested that you must first see that overall effect is there or not. If it is there, fine. If it is not there, that also fine. If it is there, find out which of the comparisons are different using one of the important tests available. Okay. So, that part is another one. This book is very good, go through this book. Okay. So, this see ultimately there are 1 versus 2, 1 versus 3, all those things are there, and design and analysis of experiments by Montgomery. If you really want to know DOE, there is no other alternative books available in the market world level. This is the best book, and my all students who attended my class on DOE, they follow this book. Author's name is D.C. Montgomery, Douglas, D-O-U-G-L-A-S-C M-O-N-T, Mont, G-O-M-E-R-Y, Montgomery, Design and Analysis of Experiments. Okay, Willie, very low cost book, very powerful book. Okay. So, now I will come to another concept. I think I have another 5-10 minutes of time. First one I want to tell you, suppose you are given another example like this, that battery life, which is dependent on material used for making the battery as well as under what temperature. Okay, maybe while making the battery, that temperature, that it is not probably experimental temperature. So, this is not a one-way ANOVA case, because in the previous example what we have said, that the power effect on each rate. Then on this side we have given all the replications, that a power 160 vis-a-vis 5 values, 180 5 values, like this. In this example what we are giving that there are 3 types of materials and 3 different temperature level, plus against each combination there are 2 replications. Okay. So, what you want to know, whether material type has effect on life of battery, this is number 1. Number 2, whether temperature has effect on the life of battery, fine. Number 3, whether the temperature and material type interaction has effect on this. So, as a result, this is a case of two-way ANOVA. Okay. Two-way ANOVA. Suppose I want to tell you, then how do you write every observation here? So, 1 will be I will be for factor 1, 1 to A, this is for factor 1, then J will be 1 to B, that is for factor 2. So, in our case factor 1 is material type, factor 2 is temperature, but in addition there is replications also. So, K equal to K1 to N, this is for replications. Okay. So, that means if I pick up any of the observation here, that will be Y I J K. Okay. So, can you not partition this? You can partition this again. Suppose you may write this one Y double triple dot bar. So, I am giving you this one grand mean, grand average, then there will be treatment A, factor 1 or factor A, I am writing this is A, this is B. So, there will be some quantity for this plus treatment B plus error. Possible. Ultimately, Yijk will be Yijk. So, okay. So, what I am now showing you that this is the general formulation up to N, 1 to A, 1 to B, and then your this one is your statistical model. What you are writing? Grand mean, treatment 1 effect, treatment 2 effect, interaction effect plus error. Okay. So, in the population domain I am writing this as mu plus tau I plus beta j plus tau beta ij plus ijk. Now, see, I can write this, but not required, because you understand the concept fully. What is it in here? Ijk minus this. This is nothing but this Yijk, this Y triple dot bar. Okay. Then you have written Yi double dot minus this, that is nothing but the treatment 1 average. This is the grand average. This is treatment 2 average, grand average. This is for error, and this one is basically interaction part. See Yij dot minus this minus this minus this. So, if you simplify this one, then if you write this and simplify this, you will be getting this one. Okay. So, dekho. So, it is very simple now for all of you. 2A ANOVA. Total sum square will be sum square for the factor A, factor B, interaction, then error. Similarly, your degrees of freedom will be for total degrees of freedom, factor A's degrees of freedom, factor B's degrees of freedom, interaction degrees of freedom, and error degrees of freedom. This will be. Suppose there are another variable, what will happen? Another factor. So, sum this total is SSA plus SSB plus SSAB plus SSC plus SSAC plus SSBC plus SSABC plus SS error. and accordingly this partitioning actually ultimately coming from the partitioning of the observation to partitioning of the contribution, deviation partitioning. Okay. So, when it goes beyond 2 manually it is laborious, ridiculous basically, but the concept was this. Now, what will be changed in the ANOVA table? One way ANOVA to 2 way ANOVA table remains same, only number of factors will be added, parameters, more number of parameters will be there. So, देखो क्या है, you see there for treatment, bit treatment, interaction, error and total. So, treatment A, treatment B, this okay, the degrees of freedom, you find out the mean square, this divided by this, second one this divided by this, third one this divided by this, like this. Always you compare with the error. MAC, always you are comparing with the error. You are thinking that if I change the label from one level to a treatment from one level to another, and actually you are inducing variances. If that variances is not different than the error variance, which is random, error variance is always random. If that is not the difference from the error variance, so what is this? That means the treatment is effect changes is random changes only. So, whatever change you are really observing in that is not a systematic part. So, fine. Now, you test F0, all computed values are there, take a null alpha value some 0.05 or something, and then compute or compare all those values whatever you are getting, and if you find out the computed value is more than the tabulated value, that effect is significant, otherwise not. And for post hoc analysis, again for A different level you compare, for B different level you compare using the Fisher LSD and Taki test, all those kind of tests are there. Only what will happen in the error term, that standard deviation part will be different, some of the degrees of freedom values will be different. Okay. So, in that way you go on finding the contribution. Please ask question. No, you always think on what is that, whether that there is effect or not. Interaction effect is there or not. Accordingly, you may be interested to have the effects, or your experience and your practical sense says that, or your physics behind the problem says there is interaction effect. So, in that case you may be always looking for that should be significant, but that is not the way things through the analysis is done. Analysis always start with a one hypothesis, null hypothesis here. Whatever experiment you have data, collected data, everything is fine. Now, my null hypothesis is no interaction effects. That is the starting point. Now, through analysis you prove that whether there is effect or not. If F0 for that is interaction is more than the tabulated value, then there is interaction. You may be happy, but otherwise you may be unhappy. But please rely on this. If you think that it is impossible to accept this null hypothesis, because you are saying there is no effect, I mean your problem lies somewhere else, that is in the design part or choosing the variable, or maybe in analysis you have done some mistake, but primarily in the design part. Getting me? Please.
Last class you said that when we have more than one factor we do the blocking.
No, blocking is not to block the important factors. Blocking is for blocking the nuisance. For example, here also you may be interested to say that the temperature effect you want to block. You can do this, but that is not the desired one, because where two-way ANOVA is available, so I will also get the effect of temperature, and you have the control on this. Okay. But even then, suppose you say no, I do not want to invest on this issue, but I want to block it. But the sense is that concept is that you try to block the nuisance factors, not the important factors which ultimately help you in designing out. If you cannot control, how can you block? That means some way in the design part you are able, you have the control. For example, material, you are taking different kind of material. That means you are choosing the material in such a manner that the effect will be controlled. Okay, and something which is totally uncontrolled, I don't think can be blocked also.
So we block a factor that we are not interested in.
We are not interested in. The cost is very high. Any more question?
So is it two-way ANOVA is equivalent to factorial design?
Factor?
Factorial design.
No. ANOVA is a technique. Factorial design is something different. Let me tell you some, if that as the time permits. When we talk about factorial design, we are basically talking about the labels. Suppose in one, these are all two-way ANOVA is not factorial design. Factorial design will tell you whether you will go for ANOVA or two-way ANOVA. For example, you have factor A with A labels. So this is a factor for different level. Suppose you have factor A and B, one with A labels, another with B labels. What design you are doing? That is factorial design. Factorial design. Factors with different labels, that is factorial design. Now there is concept called full factorial design, that I think in the next class I will be telling, otherwise Professor Mitra may be telling. Full factorial design and fractional factorial design. Now suppose you have two factors A and B, A with A label, B with B label. If you do experiment for all AB combination including N, suppose ABN combination, ABN data you are getting for AB combination, that is full factorial design.
Here N is
Replication. Replication.
Number of repetitions per each combination or total?
No, for each combination.
That means one combination.
One combination. Label factor 1 at label 1, factor 2 at label 1 in number of runs, experiments.
In this example it is 4.
In this our example, okay. Here 1, 2, 3, 4.
4.
Yeah.
N is 4.
N is 4. Everywhere it is N is. Okay. What is the unit 1, and suppose this is level 1, this is also level 1 for temperature. How many observations are there?
3 levels, each level is at
4 observations. So N is 4. This is another important, actually this one I will not tell you now. Earlier I started with this. I want to tell you this part, very important part, because this answer will answer you the second question. Still now we have answered the first part only, that does the mean differs. So that we have discussed. We have not discussed the other one, that what is the optimum level or best level of the factor that will give you optimum result. So that will be this is something interesting one which will ultimately come through response surface methodology, but the fundamental mathematics behind this is regression. What Professor Mitra has already started. So regression. For example, this is a regression equation. I think here control plot for x1 and x2. I have to see that what is this x1, x2. Maybe it is not there, not written. Whatever may be the things. What you are doing here, you are doing considering two factors. One is A and B. So A in terms of regression is x1 and B x2. So by doing experiment and then finally conducting the regression analysis, you are getting this equation. 35 y is 35.5 plus 10.5 x1, like this. And now this equation and x1 x2 is this 0.5 is considered to be negligible, that is why it is written like this x1 and x2, getting me. So, that means your y is affected by the main effects only. Intersection effect, maybe through test you found out that this 0.5 is nothing but 0 value equivalent to 0. So, it is nullified. Now, you got this one. This is nothing but graphically this one, y cap equal to 35.5 plus 10.5 x1 plus 5.5 x2, this is nothing but this, and you are getting a surface here or not? Is it a surface, the cross section? Yes, it is surface. This is response surface. What is response here? Y is response. I started with this, that output level, either quality or performance, everything will be treated as response, and the corresponding variable is response variable. So, by doing regression, you are creating a surface called response surface, like this 3-dimensional case. This is my response surface. This is my response surface. That means every point on that surface is a value of the quality variable or performance variable or output, and corresponding to that x and y values are the factor values. Suppose you take any point here, okay, and then basically project to x axis and y axis. Suppose you are projecting here, and corresponding this one, let it be coming here, somewhere here, vertical line. So, that means 0.2 and here may be 0.2, and or other way you can do one thing, take 0.2 here and go vertically up, you will meet a point here on the response surface. That point is nothing but the y value with respect to corresponding x1 and x2 values. Okay. Now, this is your response surface. Then how to once you have the equation, you can ask MATLAB to do. What will happen if this x1 x2 is taken into consideration? Here you see you are getting a flat surface, it is a flat surface, but if you consider this one, curvature will come, okay, some kind of inclined surface will be there. I do not know whether it is there or not. Yes, you see some kind of curvature is coming here, here is some kind of inclination is there, but it is not in the proportion to x1 and x2 on the both the side, because there is another variable x1 that interaction is taking into consideration. So, now interestingly you see that this is what is actually the industry people will be interested to know, and you will be, and also your paper if you submit, they will be ANOVA is fine, but beyond ANOVA you have to show. So, now you see what is this. See, all are mathematically can be derived and be shown, but time is not there. So, I am just showing you the essence of this. What are these things? Anybody?
We can treat this as an objective function to find the value of x1 and x2.
Here, this side response surface, right hand side. This one, right hand side. Here. You see there are parallel lines. What are those parallel lines? Okay. Below we have written contour. There is no interaction influence here, you see, because x1 x2 coefficient we put it to 0, that is why you got this one. Okay, so DOE, this is the magic of DOE. Now DOE with response surface. So what is this? See, x1 for different values, x2 for different values, and here you are getting some straight lines with different values or parallel.
The influence is constant irrespective of the
Change in x1 and x2. This is known as contours. For example, you join all the cities having equal annual temperature. What is this? This is the temperature contour in terms of annual average temperature. You think of a hill and equal altitude, if you join, you will get some diagram. This is nothing but all the locations having equal altitude are joined together. Here also done the same thing. From this surface, you are creating this surface, this line, you have joined. If you take any straight line here, because it is a flat surface and responsible along this straight line, all values are nothing but the same y value. So these are all equal responses. Okay. Suppose the beauty is that, suppose you want y response to be 46 or 43, then you can set x1 and x2 at different combinations. If you set x1 here, then x2 value here, you will be getting 43. Again, if you consider this point, suppose x very high value and y medium, x2 very high value and x1 medium values, you are also getting the same value. So that means you are getting a range, process setting range you are getting. Every line is response lines. On every line, this is a constant value. For example, if you take this one, this is what 28 for y, the response. So now you have the flexibility for choosing x1 from this range, and y up to this much is a bigger range you are getting. If you set x1, x2 along these two range, any value, combination value, you will be getting 28 response. That is why it is known as response surface, and this is the message. If you include x1, x2, what is happening? You see, you are no longer getting the straight lines, because interaction effect is twisting the result to some direction, and as a result, you are getting curvatures. Curve line, not curvature, better word is curve lines. Curvature is again a quadratic effect will be there, curvature, curve lines.
So in these both the diagrams, the x1 and x2 values are ranging from -1 to +1, but the actual values are
Different.
So what is the logic in converting the actual values to the -1 to 1?
And then mathematics becomes simpler here. Ultimately, when you get this, then this is nothing but you have done some kind of standardization, normalization, -1 to +1. Now what will happen? You now these values you again convert back to original values and plot here, you will get the same thing. Now see here, this is a big that curve, but along this curve all the values are y values are 31 only. So if you choose x1 here, then your x2 will be here. If you choose x1 here, x2 will be here. So you are getting a range. Please.
We have more than two independent variables. How will we?
That's true. That is another important question. Then you cannot show in this manner, pictorially difficult. So pictorially possible, you hold other, suppose x3 at a constant value, x4 at constant value, then x1 and x2 you change and show this. You are getting me? Suppose you have 4 factors. So 4 factors you want to show this response surface, either this way or suppose in the contour plot itself. So A and B you change, C at low level, sorry, D at low level. That means when C and D are at low level and A, B changes are like this. Okay. That is if you want to show pictorially. Otherwise, if you want the mathematical, just the output in tabular form, no problem, you will be getting. Change everything, you will be getting. Okay. But ultimately, this also is not the end, because you don't know who you are getting an idea. If it is a maximization problem, which direction you should go? Upper direction. So it is giving you an idea that if you increase x1 as well as increase x2, you are going towards maximum values. If it is a minimization issue, then you are going down and down. But you have to find out that location, that particular combination. that time again the second order regression you have to do, second degree, then you will be getting some curvature and so many things are there. But that if you are interested to know, then chapter 11 of Montgomery response surface methodology. And those who are from academic side, I think they all understand that response surface methodology is widely used and it is to be there, only ANOVA will not work. So, few more things I can tell you at this point. So far we are talking about only the mean values. Please understand, you are saying level means. You have not talked about the variability part, correct. So, if you want to include mean as well as variability in a model, then you have to go for joint modeling, joint optimization part. Means one equation for mean, another part for variance, and this. And the general models they are used are GLM is another a group of models, generalized linear models. So, there is one very good author, actually Neldar and somebody else is there. Neldar is this GLM, which is basically a family of regression models basically. Okay. So, so that means if you want to do research in this line, one is mean modeling, variance modeling, followed by mean and variance modeling, followed by robust optimization when the nuisance variables effect also will be nullified. So many things are there. So, I think I completed the time, but not the topic. Generalized linear model, Neldar, Neldar, Neldar. Okay. So, next class will be on primarily on partial fractional factorial or full rational factorial.